drawings like you just completed for your homework, but you laid out the product from the outside. Now you're going to lay out the product from the inside and show the client that you figured out how to put all the mechanical stuff in the shape that you've created. So this is a battery-powered fruit peeler. It's a little bit different than your drills, but the drawing principles are the same. You want to show the shape of the things inside. This motor is rectangular, this battery is round. There's a shadow underneath the top of the cover. And here it's lit up. The light's touching this. The light can't touch this, so it's dark. The light, and that shows you that that shade is going around. There's a shadow underneath the circuit board. There's a shadow underneath the blades. So you're showing the client what's inside and how it fits inside. Any questions so far? This is called, I call it component layout drawing. Some other people might call it something else, but I think most people call it component layout drawing. So what you're doing is you're cutting the product in half. Usually the product's cut in half anyway. There's a parting line, like there's a left half and a right half. But you cut it in half, or you cut it where it needs to be cut so that you can see what's inside. Some of you may need to do a cutaway as well. We talked about cutaway drawings, like let's just say it's not, but let's just say this motor was, in this view, totally covered up by the batteries. The batteries on top. Then you might need to cut away part of the batteries so that you could see the motor. I don't think with these drills you're going to need to be doing that. And I'm not going to ask you to cut away the battery pack, but I am asking you to cut away the handle and the upper body, and you should be showing the motor, the fan if there's a fan in there, the gearbox if there's a gearbox. The drill chuck you don't have to cut in half. The battery pack you don't have to cut in half. You do need to cut the handle in half and show the switch inside. There's reference information for that stuff on V2L where I suspended the drill parts in space for the exploded view drawing. You can look at that if you can't remember what's inside. You're still doing thick to thin lines, you're still doing high contrast, you're still doing shading. You're putting the basic dimensions on there again. You're going to add, for the first time, call-outs. This call-out says, I can't read it, but that one says LEDs, that one says switch, this one says cutter head. Any questions? You're going to want to use your straight edges and your French curves again, just like we did on these layout drawings. This drawing is one of the, what I call design development drawings. What are the other ones? What? No. Concept sketches are part of the ideation phase of the design process.
Orthographics in this?
What?
Orthographics in this?
Orthographics is a design development sketch. Component layout drawings is a design development sketch. Exploded view is a design development sketch or drawing. And one we haven't done yet, it'll be coming next after this, explanatory drawings. Explanatory drawings is where you have arrows that show you rotate this and the arrow is curved to show that you need to turn something to make it work. An arrow pushing in to show you need to push something in to make it work. You show a drawer pulling out, or you show a battery being disconnected. You show how do you disconnect the battery. You need to explain that with explanatory drawing, that's what we'll do after this one. Those are the design development sketches. You're developing all the details about the design and communicating that to the client. Okay? I got a new story about this kind of drawing yesterday. So yesterday I had the VP of Design and Ammunition in my classroom, and who knows about ammunition? Who knows what ammunition is besides bullets? Anybody? You don't know?
None for San Francisco.
Yeah, started by Bob Brunner
Located in San Francisco.
in San Francisco.
Then did something with Nike.
Okay, so ammunition was a spin-off from Pentagram, which was a worldwide design firm, and Pentagram spun off their ID function. They're making a lot more money doing graphic design and logo design and that kind of stuff. And so Bob Brunner started ammunition with the ID team. He was in charge of ID at Pentagram. But ammunition has been growing like crazy. It's probably the fastest growing design office in the area, maybe even the world, I don't know. It's growing very fast. They have very high-end, top-name clients, including Nike and all the big names, especially high-tech stuff. So I asked the VP of Design at Nike, why is ammunition doing so well and growing so fast compared to Ideal or Frog and these other offices? And I was very surprised at what she said. What she said was, we don't do anywhere near as much research as Ideal and Frog do. We do some research, but it's more simple, seat of the pants, qualitative, not quantitative. And we don't produce million-dollar books about market niche and business development like those two companies have been doing. Those two companies have been doing less and less product design and more market definition design. So ammunition, she said, their core strength is they know how to get a product manufactured and on the shelf. And she said, we hire plug-and-play designers. You guys know what that is? Anybody want to guess?
Ready to go?
Yeah, ready to go. You plug the designer into the office, they go right to work, and they know how to get a design all the way onto the shelf. They know more about materials and processes and this kind of thing that I'm asking you to do today than the designers at other companies. He said the designers at other companies, they do a sketch and they hand it over to the client and the client screws it up. But ammunition carries the product. They send people over to China where it's manufactured, and one of my former students who just graduated last semester is working in ammunition. He just got back from China, and what he was doing over there was taking these kind of drawings over there, talking to the engineers, and making sure that that product gets manufactured and ends up looking the way he designed it. And this is a good skill for you to get, to learn how to show the engineers that yes, they can put this stuff inside and they don't need to change the shape of the outside in order to make it work. So, some people might call this old school, but ammunition's the newest school there is in town. And they're doing this.